Welcome students. In this video, let us look at why this process of homogenization works. What is the logic of this process? So let us say that you have a general curve ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. You have a line lx plus my plus n is equal to 0. So if you take the first curve, it might represent a pair of lines or might not represent a pair of lines, depending on what the value of delta is. Suppose that you have some curve which looks like this. It can be any curve. Suppose that this curve looks like this. And you have a line lx plus my plus n is equal to 0. Now these are intersecting at 2 points A and B. Obviously, if you take the point of intersection of a quadratic with linear, you get 2 points of intersection. Now, you're asked to find the pair of lines joining the origin with these 2 points. You have to find the pair of lines OA and OB. So first, let us homogenize this equation with this equation. Let us write the equation and see what that equation represents. So let us consider this equation ax square plus 2hxy plus by square plus 2gx times lx plus my by minus n plus 2fy times lx plus my by minus n plus c times lx plus my by minus n whole square is equal to 0. So let us first consider this equation. Let us see what this equation represents. So the first thing that you need to observe is this is a homogeneous equation in xy of degree 2. So because if you see every term, this is a quadratic term, this is a quadratic term, this is a quadratic term. So 2gx into lx, x square term, quadratic, 2gx into my, xy term, quadratic, yx is quadratic, y square is quadratic, x square, y square and xy. So all the terms in this equation are quadratics. So this equation is a homogeneous equation. And we have seen that a homogeneous equation in x and y always represents pair of lines. So they represent pair of lines which start from origin with the point of intersection at origin. With point of intersection at origin. This is the first conclusion. So this equation represents a pair of lines with point of intersection at origin. Now the second point is, does this pair of lines pass through these 2 points? If I can prove that this equation gets satisfied by these 2 points A and B, does it prove that this pair of lines are this pair of lines? Yes. Because we have already seen that this represents a pair of lines through origin. Now if you arbitrarily draw any pair of lines, they won't be satisfied by A and B. So if this pair of lines satisfies these points A and B, then this equation has to represent this pair of lines. Now if this point is alpha comma beta is the point of intersection of the curve as well as line. That means alpha comma beta satisfies this equation as well as this equation. That means L alpha plus m beta plus n is equal to 0. This implies L alpha plus m beta is equal to minus n. L alpha plus m beta by minus n is equal to 1. So if you substitute alpha comma beta in this equation, these terms will become equal to 1, and what you're left is a alpha square plus 2h alpha beta plus b beta square plus 2g alpha plus 2f beta plus c, which is equal to 0 because alpha comma beta is also a point on this curve. So the point of intersections of this line and this curve satisfies this equation. It means the equation passes through A and B. So this equation represents a pair of lines through origin, and the pair of lines pass through A and B. Hence, the equation has to be the equation of these pair of lines. So that's the logic of homogenization. I hope you have understood this logic. It's a very interesting logic. Thank you.